All right. Can Calgary hear me? Quick sound check. Looks like I got everything on. We're getting close. All right. Can you hear me now? Should be no different except that I'm talking. How's that? Definitely the mic's on. I see it levels here. I just want to make sure that it. Uh, all right, great. Thank you. And I'll also speak a little bit louder once I'm not doing a test. Cool. Okay, so we can get started then. Let's do it. All right, we're ready to get started for this afternoon. I know it's the afternoon. I know we've been heads down quite a bit, but let's, I don't know, maybe everyone stand up a second. I don't know. Stand up. It's okay. I'm standing. Just stand up, yeah, because it's afternoon, and I want to make sure everyone's listening to me. I don't necessarily, like I said, for me, the goal is not necessarily that you learn all of this, because that's very difficult. But I want you to be able to listen and at least be able to ask questions in a timely fashion. So we need to be alert. So getting up is good. I was actually reading an audiobook recently, not reading, listening to an audiobook, and it talked about how everyone's schedule is kind of created differently. Like for me, I get up in the morning, I'm useless, and I work best at like after 6 o'clock at night. And I know there's people that work really well in the morning. But what it told me is that everyone has the same trough at about 2:30, 3 o'clock. Everyone's useless at that time. So I thought we'd just get up. We can all sit down now and get ready to do this. Thank you. Thanks for humoring me. All right, so more SQL. Because it's the afternoon, again, I want to focus more on just showing you what's possible. And I want to warn you against the dangers of thinking that you could probably write code faster than the database can, or execute queries faster than the database can. And why this is important is because when we learn a new language, and we already know a language, we tend to try and do as much in the old language as we can, and kind of limit ourselves in that new language because it's scary. And so I see this a lot where people will do queries to a database, and then filter and join and do all that stuff in JavaScript. But it's really slow doing that. It works, and with small data sets, you don't even notice the difference. But I want to show you some examples of where that might, get you into trouble. So You versus the database. If you create a SQL query, chances are it will get that data faster for you than you ever could write JavaScript for that. I want to get all of the students in their cohort name. This is, again, similar to this morning. In JavaScript, what I could do is have a list of all the students as objects. Let's imagine what that looks like, an array of student objects. And I also have an array of cohort objects. So I have my 2 tables of data. And I can use JavaScript to go through each student. And for each student, I can go through every cohort looking for their cohort. And then I can grab all that information, put it together in an object, and return that. And so this is what this code does right here. It's really doing a select and a from and a join, but in a different language. Okay. So if I run this in JavaScript, given that I have these 2 arrays already, it takes about 27 milliseconds on my computer to do that. But the SQL query, to do all that just from SQL, it takes 7 milliseconds. So we can see there's already a savings in time, right? I have the example here, and I'll show that to you quickly. So you could run this yourself, and the important thing to note is that if I run tests on a machine, I need to run both tests on the same machine. You might get different numbers than me, but that might be because your machine's faster or slower than mine. So make sure that when you're doing tests like this, you run test A and test B on the exact same machine. All right, so here, a basic example. What this will do is my SQL query, it'll actually just run it as an SQL query. We'll learn more about that tomorrow. When it gets the response back, it's going to find out how long it took. The JavaScript version, it's going to run the JavaScript for me instead. And then I can, yeah, don't worry about that part. So I'll just run this and see how long it takes. All right, so basic query, 21 milliseconds on my machine. SQL query, actually fewer, 3 milliseconds on this machine. So pretty fast. What about if we decided to up the complexity? How many students do we have? I'll tell you, it's about 190. How many cohorts are there? I'll tell you, it's about 12. So in this case, our data set is relatively small. 190 students, 12 cohorts. So when it does this search here, the find, it's only going through 12 cohorts every time, and that's why it's relatively fast. Let's say that instead of 12 cohorts, for every single student, we have to go through 72,000 assignment submissions. That's a way bigger number, right? So now, I want to get all the students and the number of assignments they completed. If I write the JavaScript to do that, it looks very similar, same kind of pattern. I go through every single student. That's important. But for every student, I also need to then go and filter out all the assignments just for that student and then count how many there were. And that tells me how many assignments a student completed, right? And then I put it all together and return that. So how long do we think this takes? If my last one took 27 milliseconds, now I'm doing 72,000 rows every time. How long? Guess. It's a guess is good. A guess is as good as anything. 50 milliseconds. 1.1 seconds. That's huge, right? And it was just because we had to do way more searching through this. Remember I told you about indexing? It's searching linearly through this array every time, and it's 72,000 items. So worst case, it has to go through all those items to find the thing. This is a problem. But our SQL query, it takes more time, right? But still imperceptibly more time. We can't tell the difference between 7 milliseconds and 42 milliseconds, but we can tell the difference between 27 milliseconds and 1.1 second. So we don't want to be doing this in JavaScript. We want to do as much of the data fetching as we can in SQL, and then just display the data in JavaScript. This is always going to provide a way to create faster applications, okay? So the messages, spend the time, learn SQL, you won't regret it. Even if we were to take this submission stuff and do that indexing strategy that I told you about, where we can speed things up by doing a constant lookup, it only saves me, well, I go from, I guess, 1,100 milliseconds to 712 milliseconds. It's still way slower than my 42 milliseconds for the SQL query. So even indexing didn't solve this problem for me. I wasn't able to solve the performance issue that way. Okay. So this is performance. Don't do your data manipulation in JavaScript if you can do it in SQL. The second thing is we want to talk about some scenarios. So these are more advanced queries that we might want to do. And the other reason that we don't want to do it this way is because I believe that it is easier to write bugs in the left-hand code than the right-hand code. Does anybody disagree with me on that? That it's easier to write JavaScript bugs than it is SQL bugs? And it's because JavaScript lets us get away with pretty much anything, and SQL is kind of constrained, like it gives us warnings all the time, and I really like that. I mean, they're frustrating when you're trying to learn because you're just getting errors constantly. But when you're actually trying to build things, the errors are what help you get there faster. So I would say don't write all your query stuff in JavaScript, because it's more likely you'll write bugs. And think about it as we go through this, what these complex queries might look like as JavaScript instead. All right, so let me, oh, that's bad. Let me just close. It's not bad, it's just not my, there we go, the tab that I use for browsing. Okay. I want to go to my notes here. Okay. So now what we're going to do is we're going to go through a bunch of different scenarios. And these scenarios are sort of things that maybe we'd want to, the questions we might want to ask about the data that we have. This reality of a boot camp with assignment submissions and assistance requests. Maybe we want to know some stuff about it. I want to find all the inactive cohorts, identify how many assistance requests were made per student on average. Right? Why not? Someone might be interested in that. Maybe I want to find all the students who are currently active, display the number of complete and total assignments for the program. Maybe I want to find all the teachers who are currently active, display the number of assistance requests they've completed since the beginning of December. These are all things that I might want to do, and I want to show you the queries that we would write to make this happen. And I want you to think while I'm doing that about the JavaScript that you would have to write to do that as well. It's very complex. We got 7 different scenarios. I won't be able to get through all 7 of them, probably 3, but that's okay because they're all in my notes and you can go and run these against the same data that I'm using, okay? So let's choose one. Let's start with one here. I'm just going to pick one first because it doesn't really matter which one we use. All of them kind of illustrate the same point. Let's say I want to find out how many assistance requests have been created for each assignment, right? And the way I'm going to do this is I'm going to show you the query and its results, and then we're going to write the query up from scratch, rather than me trying to get you just to imagine what the results might look like. Here's my database. Here's my query. And I'm going to use this program here to execute this query on the database. And what we'll see at the bottom is our result set. Okay, so I've executed this query on my database. And the goal again is to find all of the assignments and how many assistance requests were made per assignment. Okay? So down here I have a list of the assignment ID. The name of the assignment, they were randomly generated or like Latin or whatever, so that's why they look kind of weird here. The duration of that assignment and how many times an assistance request was made for that assignment. This is the important field right here. The number of assistance requests for it. And here's the query that I wrote to do that. Right? I want to select certain columns from this, including an aggregate that counts the assistance requests. I need to join the assignments table to the assistance request table so that I can get information from both of these tables. The condition that I want to is through that foreign key. I want an assistance request has an assignment ID foreign key, so I'm going to join them together with that. And then I'm going to group by the assignment ID so that if I get, let's say that I have 3 assignments, and the first assignment has 2 assistance requests, then that means when I group by the assistance ID, I'm going to actually get 1 bucket for that single assistance. Okay, and then I can count it. Let's build it up from scratch now. It's probably easier that way. But do we understand? I guess the main thing. Do we understand what we expect to come out of this at the end? All the assignments and how many times an assistance request was made for each assignment. All right. Select star from assistance requests. I just need to start somewhere. Don't let the fear of not knowing which table to pull from necessarily stop you from writing a query. Just start off writing this and then run it. It's super cheap to do that. I can just say, okay, well, here's all the assistance requests now, right? I've gotten that far. And what do I need to know now is for each assistance request, I might need to know which assignment it was about, right? So for that, I need to join. I need to join the assignments table because that has the information about the name of the assignment, for example, that I want to show. Join. Let's say from. I'll put this on the same line, and then we're going to join the assignments on, and this is where we decide what condition are we to write on. When I go through here, and my very first assistance request has an assignment ID of 6, well then I want to make sure that over here I have that assignment number 6's name. So I'm going to join these things together based on the assignment ID. It's going to be assistance requests dot assignment dot assignment ID is equal to the assignments dot ID. Okay, I've done a little bit. Let me run this query now, see if I get an error or if it gives me better results, things that I expected. All right. Now, I did get a little bit, I still have the same number of rows down here. But now, every single assistance request also has the data about the assignment that it was for. And so these things are joined together now. What's my next step? What's the actual end goal of this query now that we've had a little bit of time? Yes?
You want to see the name of the assignment and the number of requests.
Cool, yeah, so I want to see the name of the assignment. I've got that now. Because I joined these tables, I have the name here, so that's good. Every assignment or every assistance request has an assignment name associated with it. But what I want to do, but if I do a search here, or if I do not a search, if I sort this, for example, by the assignment ID, we can see that a lot of assistance requests have the exact same assignment ID. Therefore, we get a whole bunch of duplicated assignment names here. But what I want to do is count how many of these there are, right? How many of these assistance requests have the assignment ID of 1? It's these ones. So what's a way for me to take this large set of results and break it down into those buckets? Each bucket representing an assignment, right? Okay, yeah, let's do that. So count assignments dot ID. So this is going to take however many assignment IDs there are here and count that for me, right? It just gave me the number of rows, but that's not what I want, because that tells me how many assistance requests were made, not necessarily how many assistance requests were made for an assignment. So the part that we're missing here, group by. I need to group these assignments into their own buckets, where every bucket represents the ID of an assignment. And then when I do that, I can count each bucket, and that tells me how many assistance requests were made for that assignment. Yes? Yeah, I'm going to group by the assignment ID. Now, if I don't do this, if I have that star in there and I decide to go this way instead, we're going to get an error. And this is the error that we typically run into when we try and group by. It doesn't know, right now when I group by assignment ID and then I say I want to select star, it says, okay, but star for what? Because now we've changed the structure of this result set. We split it into these groups, and it now needs a way to identify, or at least how to handle these groups. And by it's not able to show these. It's not able to show the groups because they're going to take multiple rows, but we've grouped them all together into this sort of bucket idea. So I want to convert that now into the count. And this is going to count for every group that I created with the group by clause. Oops. Assignments. I got to spell it right. That's definitely a prereq. Assignments ID. Assignments ID there. Let's do that. All right. All right, so now what did I get? I got 424 rows. How many assignments are there? You don't know. There's 424. I know that. But what this did is because we grouped by the assignment ID, we're going to get that the number of assignments back worth of rows. That's the number of buckets that we have. Does that make sense? Yeah? Okay. So when I count this, it takes that bucket, counts all the things in it, gives me back one number, and I get that value right here. And then it does the next bucket, puts that together, counts it, gives me the next bucket as far as the data. So I don't know what these counts are related to. So now is when I would think, okay, let me take the assignment name and add it to this query now. So I should see assignment name and the number of assistance requests for that. Here they are. Maybe the ID is interesting to me, so I go back up. And so now it gives me the ID, the name of the assignment, and then the number of times that the assistance request was made for it. I could order by ID. I could order by the count. I could say order by, and then I have to say count assistance assignment .id. Maybe descending so that it starts at the high numbers, and execute that. Now I've gotten pretty, except for the duration thing, which I don't really care about. I've now got that result that I wanted. It has the ID of the assignment and how many times an assistance request was made for that. I don't really like the name of this column count because it doesn't really tell me what it is. But anytime I run into that situation, I just alias the name of it. Maybe AR is created or something like that. And so now AR is created is the name of that column. I can really structure this result in the way that I want. And then in the UI, it's a lot easier to access this than something called count that might be random, right? So these do come back as the columns in the result. Okay, so you see, I didn't just go and write that query. I started with what I knew and then started to modify it until I got to the point where it gave me the data that I wanted. And we can do that with any of these. We can do interesting things like, oh, this is a good one. So find out which assignments a student hasn't finished, a specific student hasn't finished. That might be useful. And it's not just useful for me, right? Or for you. I think it would be useful for you. You come in the morning and here's all the assignments you haven't finished yet. It's a good list. Might be useful for someone else as well. Maybe Davey wants to know which assignments haven't been completed. So this query could be useful. Let's take this, paste it in here. We'll just see the results first. Not the right one. That's totally didn't copy properly. Let's do that. Come on. Oh, of course I do. What did I have a different thing open? I thought did I not select this? I don't know. I thought maybe I was in another tab. Who knows? Okay, that's better. Thank you. All right, so I execute this. And this is for one student. The student with the ID 159. So it says I want to, I'm going to join it whenever the assignment submission student ID is 159. So I could actually put in 1 and it's a different student. They've finished all the assignments. 160. They finished most of the assignments. They've got, I don't know, about 80 left. So this way we can limit it just to one student. What else? Yeah, so that is giving us the result we want. But let's start it over from scratch again. Select star from assignments. I think let's do assignments. Yeah, select star from assignments. Now, when I run this, it's going to tell me that there are 424 rows. Now, what I might want to do is for each of these assignments, I'm going to join it to an assignment submission so that I know which assignments have been submitted already. So I'm taking the assignment ID from join assignment submissions on assignment. Oh, it's so much typing, right? So I'm going to join the assignment submissions table where the assignment submissions assignment ID is equal to the assignments.id. Now, I should get many more rows. 72,000 rows now. Because I'm joining this other table in that has way more rows, that's the number of results that I'm going to get. I can sort this by the ID, and we can see that we have that same assignment duplicated a number of times. But the difference between all these entries is that it was a different student who submitted that assignment. So this is actually all the assignments that have been submitted. We know which student submitted it, and we know what assignment it is. And so now, let's say assignment submissions. Here I'm going to say, well, I actually only care about the assignment submissions where the student ID is 159. So this is now limited down to 257 rows. That seems more reasonable. 72,000 seemed like way too much, right? But 257, what do we think that represents? Yeah, exactly. So we have the opposite of what we want. We know which assignments that student has submitted, and there's 257 of them that were submitted, but we want to know which ones they didn't submit yet, right? So part of the problem here is that I'm not getting any assignments that were not actually submitted. I'm only getting the assignments that were submitted. We had a solution for this problem this morning, and I want to make sure I give you an opportunity first to see if you can tell me how I would change the behavior of this before I tell you what the answer is. Right? We don't want a list of we don't necessarily want a list of all of the assignments that were finished or submitted. We want a list of all the assignments, right? And we want to know which one, and then we'll know which ones are submitted because they won't have null values for the student ID and all that, right? Sorry? An outer join. Yeah, so an outer join probably would give us what we want. Exactly. Because it's an inner join, anything that doesn't match that condition is going to be left out of the results. But if I make this an outer join, remember it just left join. Now I'm going to get all of the assignments. It's on the left side of the join. Right? All of the assignments from the left side of the join, and when there is an assignment submission that matches that assignment, we'll attach that data to it, but otherwise we'll just fill with null. Oh, actually. So I've now moved that where clause up here, and I'm joining on these two conditions. And I want to make sure, yeah, even if these conditions aren't met, or actually, yeah, sorry? I took the where out, and I'm actually going to be doing that condition in here. So I'm saying, go through, grab the first assignment, number 1, and then join the assignment submission to it. And as long as the assignment ID matches, and the student's ID is 159, we'll join it. Okay. Otherwise, the reason why I can't do we're student assignment submissions dot student. All right, so let's talk quickly about why this has to assign submission. There we go. So let's talk quickly why this doesn't give me the result I want. See, there's only 257 rows here, and it's because I'm only gonna be selecting all the assignment submissions where student ID is 159, and there's only 257 of those. So then when I join these things together, it's not going to have that outer join behavior. It's already removed all this. It's only considering those first 257 rows here, whereas here when I add these together, then it happens at the join level, and I'm going to get the left join behavior, which is going to be all of the assignments, and then fill in nulls for the things that don't match. Is that kind of yeah. Yeah, so let's take a look at this without the left join. Without the left join, like I do have these two conditions. Yes, one, that the assignment and the assignment submission matches assignment IDs. That's critical. But I only care about the assignments for a specific student, and I want to make sure that I start off by getting all the assignments. So if I do it this way, if I do it with an inner join, it doesn't really matter what I do. I'm getting 257 rows back, because anything that doesn't match that condition, it's going to just fill. It's not even going to include in that row result set, right? But as soon as I make this an outer join, then it's going to only care really about the rows inside the assignments table, and when things don't match, it'll include null for me instead. It'll have rows that represent those assignments, but it won't have the assignment submission data for those assignments because it doesn't exist. That's only with with an outer join though. So I feel like I didn't answer. Maybe we try. Okay, so I go back to join. This condition is not met for a number of assignments. Therefore, we only get 257 rows back. It doesn't really matter if I do. Actually, here it does. This matters. I'm going to get all the rows. So the fact that I have my student ID, that actually really limits the initial result set. I need to make sure that this is happening as an outer join, because I want to make sure that it goes through all of the assignments, including those that have been submitted. So when I run this, I go from 257 rows to 424 rows, which that's how many assignments I have. And now my result set has all of the assignments. And we can see over here on the right side, we can see that there's data for the assignments that match that condition, and there's no data for the assignments that don't match that condition. And that's because these assignments have not been submitted yet. So I've got what I want, but it's in this result set that includes both. So I need to do a bit more filtering, right, to only have the assignments that were not completed. How could I filter out so that it only showed me the assignments that were completed? Anyone? Yeah. I could count the null values. So if I want to count the null values, it might make sense just to remove the non-null values first, right? Because right now, if I do a count in here, count assignments.id, for example, that's going to give me back 424. Or sorry, 424 is the actual value. But what I want to do is filter out this list and only have the items that were not finished yet, and then count it. Yes. Right. So we could just say, for example, we could say, for example, where assignments.id is null, that would be okay. Where any of these would work technically, but I think that using the primary key makes sense. So I'm going to say where assignments.id is null, and this is actually how you have to do null checks in SQL. You don't do equals null. You say is null or is not null. It didn't match it. I'm not sure. I think, yeah. Oh, where assignments ID is. Is that really what I want to do? Oh. Yeah. Assignment submissions. I was looking at the wrong table. So let me get back to where I was so I don't confuse it. Okay, so here I made the mistake because I was actually doing it based on the assignments ID, which is actually over here. That's not what I want. It's the assignment submissions ID, which is over here. That's actually what I need to do a where clause on. So where assignment submissions dot ID is null. All right. Yeah, thank you. Okay. I get 167 rows back from that. So now it's only giving me the items that have an assignment submissions ID of null. And here's where I could count that, right? And I could put the I guess I don't have the student's name, right? I don't know what their name is. I haven't joined that table in there. Do we want to add that? If we left this out, let's see. No. Okay. So yeah, let's leave that in there. So we say that this student has not completed 167 assignments, but we actually want to figure out which assignments they haven't finished. So it's not the count here that we're after. It's the assignments.id and the assignment's name. And we could, I guess, order by ID. Ascending is default, I believe. So here we start at 258, 259, all the way up to 424. These are the assignments that single user has not completed yet, right? Kind of makes sense? Again, the whole point is not necessarily to be able to sit down and just write this query. It's to show that, you know, even like I do this and I have to kind of put these together piece by piece, check the data. Is it the number of rows that I would expect? Is it the data that I would expect? And then work from that and get closer to what I really want. And I think it's partially this process that that will allow us to feel more comfortable in SQL, that will allow us to spend less time maybe trying to do the same thing in JavaScript, is just by getting more comfortable starting this process. I don't know. How do you feel? It's okay. It's an okay example. Okay. So we're getting I got more here. Just so if anyone was curious about trying these things on their own, I'm going to go back to my morning notes, and I've got this directory here called Bootcamp. And if you were to create a database yourself, which I think everyone's done so far, right? Everyone's created a database in Postgres. If you create that database, you could take this file and you could run this file, do a /i or whatever, import this into your database, and then you would have a teachers table, a cohorts table, a students table, etc. Right? It makes sense? And then I have the seed file here, seed.sql. If you ran that as well, it's going to take these 72,000 submissions and the 24,000 assistance requests and all the students and all the teachers and insert them into your database for you. Showing this, I don't think it works because it's 17 megabytes, because it's just a big chunk of data. I can actually show you. I'm going to show you what it actually looks like. It's this file here, and it's just a whole bunch of insert statements with all the data that I'm using today. So you could very easily take this data, put it into your database, and then start to run and play with these queries. And that's my recommendation if you want to get more experience. To work with a large data set and try things out. Ask questions about the data, understand the ERD and the structure of the data, and then figure out like what questions could I ask of this data. There's really cool things you can do with date, for example. So this one here, find all the active students, display their requests per day. This is a challenge because I need to find out how many assistance requests a student has made, and then I also need to figure out how long they've been in the program, right? Because a student in the senior cohort versus a student in the junior cohort, they've been in the program for different number of days, and they have a different number of assistance requests. But for us to get the actual number of assistance requests per day, we have to know specifically how long that student's been in the program. So with Postgres, we can do stuff like this. Let me just run. It's so easy to copy and paste. I'll just do that. Although we won't have time to go through in detail. So here we go. I run this, and it tells me that Hedinger makes 1.8 assistance requests per day, and the student rating on average is 1.7. So I'd say this is a student that's struggling but not asking for the help they need, whereas this student down here is struggling, but they're asking twice as many times for help. Right? Let's look at what this date part looks like. All I'm doing is taking this part here, and we're going to see that Hetty has been in the program for 15 days. It's the time between the first day of January and the student start date. Just so you know, this data ends on January 1st, 2019. That's just the way it is. So I wanted to say the day that it is today minus when the student started. What does that give me? Yeah, the number of days the student has been in the program. I didn't take into consideration weekends and all that. But we can see here that some of these students have been in the program for 15 days, and some of these students have been in the program for 43 days. And that's because these are all active students, and some are juniors and some are seniors. And the reason why it's only active students is because the student's end date has to be null, and that means that they've not finished yet. Whereas all the students that have finished so far, their end date is not null, therefore they wouldn't get included in these results. All right. So yeah, I definitely recommend play around with that, and we'll move on to the next kind of concept that I want to talk to you about. Is performance. I kind of hesitated bringing this up early on because it's like, well, what does performance matter if I can't even make queries yet, right? But it's just kind of a heads up for where we're going. So when I think about these things, it's all about sort of like this balance. You have a situation here. We made this query, and what it does is, I'll run it so you can see. So what this query is going to do is it's going to find all of the students, and for every single student, it's going to give me back an array of the assignments they haven't completed. So this is now, instead of what we had before, which is I want to know which assignments a specific student haven't completed, this is going to give me back all of the students and the assignments they've not completed. That took a while. Did anyone notice how long that took for that query to run? And we can see down in the bottom corner it said it took 1.4 seconds to run this query. And it's relatively complex, but it's complex because we're doing this thing on a lot of different students. So for every single student, we have to go through all of the assignments and figure out which ones are sort of that inverse that we did with the left join and the not null and all that. So this is basically that same query that I used before here. And that took a lot of time. But my question for you is, who care? Like, is there any situation where you care about all of the students and which assignments they've not completed? Or do you just care about yourselves? It's okay in this case. When you walk in the morning, you don't necessarily need a list of all the students and which assignments they've not completed. That's useless for you. What you do need is just your list of assignments you've not completed. That could be useful. But I would say that there is someone who does care about this. And who is it? Sorry? Educators. Yeah, we care about it. Davey specifically cares about it. He wants to know maybe who's falling behind, give help early. Program's too short to let that go on for too long, right? So this query takes a long time, right? It takes a long time to run. Let's say, yeah, a second is a long time. If we start to categorize these things based on how long they take and how often they're run, we can determine how important the performance is to us. So that query, let's say it's a long-running query, right? Fits down in the lower quadrant, maybe the lower half of this diagram, right? But how often would that query get called realistically? And the real question is, how often would Davey need to check to see how many assignments are not completed? Yeah, that sounds good. I don't think it would be every hour or every day. Maybe once a week. So maybe every Monday or something like that it happens. So does that get called often? Or few or many times? Yeah, we'd say few times. So when it comes down to it, even though it takes a second and a half to run the query, I'm going to put it into the lower left quadrant because it is not called that often, so the impact is reduced. And I only really want to worry about the things that are called take a long time and are called often. That's what I want to spend time optimizing. So we make this decision, right? Does it take a long time? Yes, it takes a long time. Does it get called a lot? No, it doesn't. So maybe it's not that big of a deal. Let's look at this other query here. It's the exact same thing, except instead of all of the students, I'm only going to look for one student, and that happens to be old 159 again, right? I run this. That took a lot less time, right? 8 milliseconds, it's like nothing. And it only gave me one result back, but it is the result I wanted. It was for that user, the assignments that have been completed. So I feel like if we look at this here, is that a short or a long query? Okay, short, right? Yeah, 8 milliseconds is short. If you think that's long, need more hardware, I guess, right? So it's short, but how often does it get called? Potentially. Many. Yeah, it could be many. I mean, if let's say everyone comes in and at the exact same time in the morning, they all refresh the browser. You all refresh the browser to all get this information. Maybe that's 15 or so times, but I would say that would be more on the many side than the other one, right? Because you might just be hitting that refresh button in your browser every 5 minutes, and that starts to get on the many requests being made to the server. So I would say that request fits in the many but short quadrant, right? So I'm still not super worried about it when it comes to performance. Anything that doesn't take a long time and doesn't ever get called, that's basically just a write-off, right? So this is what we care about. And it's true for database queries, it's true for HTTP requests, it's true for anything, functions that get called. If they take a long time but don't get called often, not a big deal. If they get called often, don't take a long time, not a big deal. But if they take a long time and they get called all the time, we want to spend effort actually reducing that time. Yeah, my final thoughts. So it's overwhelming to learn this language in a day. I'd say impossible, but we're trying anyways, right? My recommendation is not to worry at all about the speed of your queries today. Just get them working, get the data you want in the way that you can. And once you've learned the language, then these discussions on performance are going to make more sense after that, right? And there are things that we can do to make our databases faster. One of them is increase the hardware. Another one is use things like indexing and caching and all these techniques that we can use to make our apps fast. But this week is not about that at all. This week is about querying databases. That's what we need to be focusing on. So I'm only highlighting this as something that is important in the future. But yeah, I think for this week you just want to be focusing on learning these on learning these 6 select from where having group by. Nail those, and if you nail those, then SQL becomes quite a bit easier. Yeah, that's it for me today, and I hope if anyone has any questions, they've asked them or they will ask them privately. And other than that, good luck with your queries, I guess. If you want to set this up in your database and try these things, and you're having trouble, please let me know. Even just message me on Slack if I'm not here. Wouldn't take me long to help you get it set up. And you get to that kind of practice, which is, to me, the most useful. I don't find that querying on a database with 2 tables with a couple of rows in each table is very useful for learning this stuff. And so I tried to provide hundreds of thousands of rows for you to query. Okay. Thank you.